So I'm going to go through the equation of photosynthesis. Photosynthesis is literally using the light energy and turning the light energy into a chemical energy, which is known as glucose. And the plants then store the glucose as a polysaccharide, a long chain, which we call starch. So let's go right into it. So you got carbon dioxide, you got water, and then you add some light to it, and you get glucose, and you get good old-fashioned oxygen. Now, what you can write this out is the chemical equation, which is CO2. That's what carbon dioxide is. Water is H2O. And then you do need to know what glucose, the chemical symbol for glucose is. You know that it's carbon, hydrogen, and oxygen. It's got 6 carbon, double the amount of hydrogen, and an equal amount of oxygen. So the 6 carbon is, you just double it and you get the number of hydrogen. And you could think about it however you like. You could think about it, it's CHO, carbon, hydrogen, oxygen. Okay. Then it's 6. If you know the 6, then you're going to say double, 12, half, 6. Right? Or you could think of it as 6, 12, and then back to the original number, whichever way you like to think about it. And the oxygen is O2. Now, this equation isn't balanced, so you've got to put a 6 over there, a 6 over there. I'm not going to teach you how to balance an equation. You're just going to have to memorize this. It's a bit of chemistry to know that they have an equal amount of atoms on one side and an equal number of atoms on the other side. Now, instead of light, what you can write is chlorophyll, which is what captures the light. It's the green pigment found in the chloroplast. So the chloroplast is where photosynthesis takes place, and the chlorophyll is the green pigment, the green color that actually absorbs the light. So photosynthesis captures the light energy and stores it as a chemical energy source. We break down the chemical energy to give us kinetic energy. That's a bit of physics there. Now, with this energy, with the glucose, what you can do is something known as aerobic respiration that produces the most energy compared to anaerobic respiration. Anaerobic doesn't use oxygen, aerobic uses oxygen. So what we can do is we could use the glucose, we could add some oxygen to it, and what it ends up producing is carbon dioxide, CO2, plus some water, and as well as what we really want, which is the energy. Now, to balance this equation, you just put a 6, you put a 6, put a 6, and the glucose, you know what glucose is. It's C6H, then remember double, and then it go back to half of it. So that is basically the balanced equation, has an equal number of atoms on both sides. That is the aerobic respiration equation. I do suggest that you memorize it if you are doing your GCSE, IGCSE higher levels. So what I can see is the photosynthesis equation is kind of like the opposite of the aerobic respiration. You're just kind of like switching between the two. Photosynthesis releases oxygen to the environment, and then we use that oxygen and we use all the products essentially that the photosynthesis gives us, the oxygen and the glucose, and we use that to create the carbon dioxide, the water vapor, and the energy. So the carbon dioxide and the water vapor, which is produced over here, right over there, that is used over here to, with light to produce that glucose.